So why do we want the LSRL? Well, we're trying to predict for the future or predict about our population. And so once we scatter plot the data, we can create this prediction line, and that's really what an LSRL is a prediction line. So we use it to predict. And if we're predicting with an X value that's outside the domain, it's called extrapolating. And if we're predicting with an X value that's inside the domain, it's called interpolating. And interpolating is always fine. Extrapolating can get iffy dependent upon how far out that X value is from the domain. And you'll see sometimes it doesn't make sense. When we use X values, we come up with answers that we say, that just seems ridiculous. And the reason is because we're extrapolating. Okay, so when you go back to that graph where I was drawing in the vertical lines in green in the last video, those vertical lines are called residuals. And those residuals are the difference between the actual dot, the Y value of the actual dot, and difference between Y value actual and the predicted Y value. Now, keep in mind the predicted Y value is the one that's on the line, because that least squares regression line is my prediction model. And so here's how I remember RAP. I know you're all RAP artists. So residual, that's the R, equals actual minus predicted. RAP. And another way to say it, or another way to write it, is the resid equals Y minus, and here's the really super important part, you have to fix this, is Y minus Y hat. And Y hat is a predicted Y value. So predicted value for Y given by the regression line. And of course, here's where it gets a little cray-cray, because your graphing calculator has both of these forms in it, and then that makes students crazy, and I say stop going crazy, because you just have to remember slope always sits in front of x. Just always go back to y equals mx plus b and what you know about it. So whichever value is sitting in front of x, doesn't matter where x is, you poke around for it till you find it, and the number in front is the slope, and the number not next to x is the y-intercept. Okay, so now you have some formulas, again, on your formula sheet for how to find slope and also how to generate the y-intercept. I want you to poke around on that formula sheet and see if you can find something on the formulas that looks something like this. It's slightly different. Again, we'll talk about that in class tomorrow. But generally speaking, I can find slope if I know my r value and I know the standard deviation for the y's, and I know the standard deviation for the x's. That'll generate my slope. In this case, b is slope. That's not this version over here to the right. It was the other version that I had, which was y hat equals bx plus a. And I can find the intercept if I know the mean of the y values and the b that I just generated, and the mean of the x values. And one thing to note is every least squares regression line goes through the two mean values as a point. So the mean of the x's and the mean of the y's is a dot on every single least squares regression line. As a matter of fact, it goes smack dab through the center of that.